Welcome, and thank you for joining us for the CMM Wizard, an improved tool for consequence assessment. This presentation is given to you by Xiaoying Yu, Matthew Sturavant, and Brett Simpson. Dr. Yu is a chief scientist at Pacific Northwest National Laboratory. She is trained as a chemist at the University of Michigan and has more than 20 years of research experience in chemical imaging, novel instrument development, kinetics, aerosol sciences, and emergency response. Dr. Yu has worked on the DOE Chemical Mixture Methodology since 2007. She has served as the Chemical Exposure and Mixture Working Group Chair since 2011, and now the STARS Chemical Mixture and Exposure Working Group Chair since 2018. Mr. Matthew Sturavant is a software engineer at Pacific Northwest National Laboratory. He has multiple years of experience in software engineering, developing many single-page applications and working on many content management systems, and has developed the base code of the CMM Wizard. Mr. Brett Simpson is a data scientist at PNNL. Prior to joining PNNL, he worked at the Hanford site. He has over 25 years of experience in engineering, data analysis, and quantitative modeling experience. Brett's projects support risk and decision sciences, specifically risk modeling and analysis. And without further ado, I'm turning the virtual stage over to Xiaoying, Matthew, and Brett.
Welcome to our presentation. I'm Brett Simpson, along with my teammates Xiaoying Yu and Matt Sturdivant from Pacific Northwest National Laboratories. We will demonstrate a software tool, the Chemical Mixture Model Wizard, for use in consequent management and emergency planning at the Department of Energy for potential airborne releases of hazardous chemicals. An airborne release of hazardous chemicals can happen in a lot of different ways and with a lot of different variations. There can be a single chemical of interest from a release or an explosion. Several chemicals can be released at once, or multiple chemicals from different facilities that can be combined and present an exposure hazard downwind from the source. A question in consequence analysis and event planning is, how would you present the health and safety impacts when there are more than one chemical involved? In this case, we've developed a method using a software tool that does a calculation that can be used to evaluate the receptor concentrations at various locations and determine what the hazard is.
Let me take you through a few examples of the CMM Wizard and its various applications. In these cases, I will develop mixtures, identify receptors, define the meteorological conditions, demonstrate result reporting and downloading, and demonstrate importing saved scenarios. There are over 3,000 chemicals in the database. They are searchable by common name, CAS number, and SAX number. So in this case, let me develop a new mixture, and it's very straightforward to do. I'll start with a simple mixture of 4 chemicals. And in this case, sodium nitrate comes right up. One of the things that is useful is if they are close in spelling, using the CAS number prevents you from making a mistake. And selecting sodium nitrate is simple. Then these can be individually deleted or replaced as you need to. and sodium chromate. After selecting the receptors, then create a receptor. And in this case, you can also switch between a tabbed view or a gridded view, whichever one is preferable for how one wants to enter data. One very convenient feature of the application is it will alphabetize your chemical lists so you have the same listing each time consistently, and that can be very useful if you need to modify or change a mixture and not have to revisit what's going on in your concentrations. The data entry is all in consistent units. The meteorological data can be entered in preserving the scenario for future modeling. The chemical mixture model does not do anything with this information. It is used for subsequent dispersion modeling. And in this case, you can move directly to the results page. So in this case, the results need to be moved from the pack value all to pack 2, and then the section can be expanded. And in this case, none of the specific agents have a HI greater than 1, but the sum at the receptor is greater than 1. To see what the individual target organ system values are, this employs the HCN numbers, and several of the system HIs are greater than 1. Similarly, the specific target organ effect provides several values for the hazard index greater than 1 as well. Note that those that are greater than 1 are in red text, and from here, these results are planned to be exported to an external reporting file, and the scenario can be exported as a specific file that can be shared. A very convenient feature of this software is being able to roll back to the beginning, clear the selection, and begin with another set of chemicals. In this case, there will be a 14 component example. And the autocomplete gives you a lot of options in what can be selected, and making sure that you have the right set of chemicals. So there we have a 14 component mixture with all of the information alphabetized. So once you have your list of concentrations, this part becomes a relatively easy keyboarding exercise. One of the things that is required is there has to be a default receptor. Otherwise, you can't advance through the workflow. And again, we do not need the values here. Move to the default receptor or default pack level of the pack 2. And that the sum of the HIs in this case are greater than 1. And when evaluating in the different HCN number scenarios, you have several of the systems that are much, much higher than 1. In fact, there's a lot of red in this example. Now, one of the things that I'll do now is come in and start over and have and load an example that I've pre-functioned and added a separate receptor. And so now, before we go back, in this case, you can look at the grid, and there are now 2 receptors, one with 10 times less concentration than the other. Again, the meteorological data is not relevant. You can see the comparison between the 2 receptors and results. And in this case, you can expand the section and look at the summary values, and then look at the systemic effects either from target organ systems or specific target organ. These files can now, these exported files can be shared and used by others, and they can be tailored and modified or additional receptors added as more information is gathered.
So the technologies we use to achieve this. We've developed the CMM Wizard using a microservices architecture style, which means that whenever possible, each piece of the application was compartmentalized in a way that makes each piece only loosely coupled with the others. This provides many advantages over a monolithic application when it comes to maintainability and a technology upgrade path. The backend service to handle data storage and authentication was written in the .NET Core framework, and the front-end user face was developed using React.js, both of which are popular libraries with a long lifecycle. With CMM Wizard 1.1, we have created an online application to interface with the chemical mixture methodology data with a similar but more user-friendly workflow to develop chemical mixtures. In this version, there's no limit imposed on the user as to how many chemicals are in the mixture or at how many receptors the mixture was detected at. The resulting hazard index values and TOS and STO values can also be calculated at all 3 pack values simultaneously for comparative purposes. Weather data can be entered for the scenario for future modeling and is included in the JSON export of the mixture. These exported JSON files are used to save the mixture, reload it into the application, or they can be emailed to others to share their scenario. The results can also be printed if needed. As you saw in the demo, the user starts by inputting the chemicals in the mixture. They can search the list of available chemicals by name, CAS number, or SAX number. The user then enters the receptors that the chemical mixture is detected at and inputs the detected concentrations of each chemical at the receptor. Optionally, the user can enter weather data, which isn't used in the CMM, but could later be used for dispersion modeling. On the results page, the user can filter the data by methodology, receptor, and desired pack value. As mentioned before, the scenarios can be saved as well as the results. Because of our technology architecture decisions, the application can be packaged to run in an offline mode, such as a Windows application.
Well, thanks, Brad and Matthew, for their exciting demonstration of the new CMM Wizard tool. Now we see how it works. We're going to also learn a little bit about the science behind it. In order to do the consequence assessment of chemical mixtures, we need to actually first calculate the hazard index defined here. Basically, it's a ratio of two concentrations. This concentration I actually represents the air concentration of a chemical at a designated receptor location downwind from the source, namely if a step is exposed at a certain location, a potential location. And this limit I sub I really refers to a designated concentration limit. In our CMM methodology, we use PAC2 value as a default concentration limit. You can also choose other concentration limits for your specific applications. We do have that flexibility. And this I here refers to any given chemical that you may have in the chemical mixture. We mentioned a lot that PAC2 is a very important value for us to use to take protective actions for consequence assessment analysis. When the HI or hazard index is smaller than 1, that means the chemical concentration that a personnel may be exposed to does not exceed the indicated PAC2 value. When it's equal to 1, that means it is equal to that indicated concentration limit. Precaution should really be considered. When it's bigger than 1, the chemical concentration exceeds the PAC2 value. Protective action really should be taken into account, and planning should be done accordingly. When we look at the exposure to chemical mixtures, we actually use the simple sum of HIs. It's very simple math as shown here. You add all the hazard indices of all the chemicals together. That arrives to the sum of HI. However, the health impacts of these chemicals are not often directly nearly additive. A better solution really should be identifying and classifying the different effects of these hazard chemicals according to their biological systems that they may impact. This process involves the development and application of health code numbers, and we'll give you more details in the next few slides. We use health code numbers to help us classify and group how the chemicals act on different body systems. We need to be mindful, though, our CMM approach doesn't cover chemical reactions that produce new products or endogo transformations. Also, synergistic or antagonistic impacts are not really covered in the CMM. This is because a lot of the science haven't really been fully developed. So right now we're using this very practical, cumulative, additive approach. Now we can take a look at the chemical mixtures, a couple of examples we present here in the bottom to see when we're really looking at a problem, how we address and apply the chemical mixture methodology. So like we mentioned, this mixture problem is not that easy to address. The health impacts of chemicals are not always linearly additive. Sometimes you could be lucky, like we're showing here in the bottom left here, you have two chemicals, assuming they each represent an HI of 0.6. Now your sum of HI is 1.2. That means, yes, it's bigger than 1. Then we do have this potential hazard from respiratory irritants. And in this case, we should provide PPE or protective actions to protect our staff in respiratory tract. And here we're indicating respiratory irritants. However, you can also have a different scenario as we listed here on the bottom right. You can have each chemical still representing an HI 0.6, the sum of HI is 1.2. But when you look more closely into these two chemicals, one chemical A could be affecting your respiratory tract, whereas chemical B may be targeting your liver system. In this case, these two toxic effects shouldn't be added together. In fact, house code numbers actually would bind them to two different target system effects. And this is actually less conservative, more realistic. So this is actually a very good example to show you that how HCN and CMM help you reduce conservatism in dealing with mixture exposure. As I indicate earlier, we use house code numbers to do this classification. House code numbers are very similar to medical diagnostic codes. This was initially developed by NIOSH, mostly focused on chronic effects. Doug Craig led earlier development back in the 90s. We added a lot of acute toxic effects as illustrated in this table. These blue-colored house code numbers all are used to describe acute toxic effects. And the red-coded numbers, these were used to describe the chronic toxic effects. Overall, we have 60 different house code numbers for characterizing the potential adverse health effects associated with exposure to a chemical. Acute effects are really the most important factors we use in an emergency event. We do develop the parallel chronic information if available. However, the data set and our methodology really focus on the acute effects, as you see in the earlier demo. We have a really high QA/QC standard for house code number development. Here we have a list of the about 10, 11 major sources we use. As I mentioned, the method was first pioneered by Dr. Doug Craig, and development procedure was summarized and published by Rocky Petrocci in 2001. I also have published 2 papers in 2010, 2011, showing the expansion of the acute house code numbers, as well as weighting factors development to help us make better consequence assessment analysis. I just want to quickly show you the data sources we use. The most important one is actually EGO, the acute exposure guideline levels. This is the same as we use in developed PAC values. The second most important source is ERPG, and that is the Emergency Response Planning Guidelines. We also use a reliable database like RTAX, HSDB, CRIS, NIOSH Pocket Guidelines, and so on. And lastly, of course, most importantly, the TLVs and BEIs. So you can rest assured our house code numbers are developed reliably for your application. So now we want to summarize the CMM workflow. We use the same workflow in the more traditional CMM workbook in an Excel format and more user-friendly CMM Wizard you just saw. To assess a mixture toxicity, first we calculate the HI for each individual chemical in the mixture. Then we come to the sum of HIs, or the simple sum of HI. If the sum of HIs is smaller or equal to 1, then no further analysis is needed. However, as you've seen in the demo and in our Excel workbook, we still highlight any of the sum of HIs that's bigger than 0.5, so that to alert the emergency responders or planners that you still need to take precaution for these type of chemical mixtures. In the method, it does require further analysis when the sum of HI is bigger than 1. In this situation, we would employ the house code number-based approach to classify and group the potential toxic effects for a particular target organ separately. In this case, we will arrive another sum of HI. This is particular to a target organ or organ system. When the sum of HI dot P is bigger than 1, in this case, we definitely need to take serious protective actions. That means the exposure is significant. Similarly, if the sum of HI for a particular target organ is smaller or equal to 1, the method doesn't call for any further analysis. However, we do give you the alarm sign in our method when the sum of HI for each organ is 0.5 or bigger. That still alert the emergency responder, planner, and manager to consider the situation and prepare ahead of time. Finally, I would like to represent our team to thank the NA41 for the programmatic support. Really appreciate the opportunity to advance the tool for the DOE communities and our users. We'd be happy to answer any questions.
Thank you for your presentation, Xiaoying, Matthew, and Brett. Before we open the floor for the questions, we have had a comment from your colleague, Cliff Glantz. His comment is, I cannot stress enough that the receptor name should include its downwind distance, and meteorological information should always be added for QA purposes. It tells you what data were used to generate your input concentration values. Would any of you like to respond to that before we go on to the questions?
Well, thanks, Cliff. That is certainly a great suggestion. I know that our software team has been experimenting the best presentation style and format, and we have the lead here, Brett. And Brett can also comment on that, and we can certainly work with you and others to make it better. Brett, you want to add to it?
Sure. There's no question that for data integrity and preservation purposes, that information should be recorded. The intent was that if someone was doing a what if scenario and was just wanting to see what would happen before entering meteorological or receptor distance information, they could get a preview before further information was used in CFD modeling or other kinds of purposes.
Thank you both. We have a question. It says, what is the difference between the CMM Wizard and the CMM Excel Workbook?
I think we can have our software development team to introduce that. We've been going between these two formats. So Matt or Brett?
So the Excel Workbook format was the foundation and inspiration for the internet-based or the web-based wizard. We wanted something that was a little more approachable and not tied to a specific software platform, although Microsoft Excel is ubiquitous in people's lives doing calculations. And also, ultimately, there will be an Electron version of this application, which once downloaded, you can work with it offline, and it'll work as a resident web application, regardless of whether you are connected to the internet or not.
I just want to add that the data we use and methodology remain the same. So if you're familiar with the more traditional Excel workbook, the same methodology is applied here. It's just more flexible to use the CMM Wizard. That has been the effort of our CMM support team for many years, and we really hope that you can enjoy the more user-friendly Wizard version and use that more often in the future.
Thank you. John Ciolik has asked, have you thought of breaking out the CMM engine from the rest of the code, perhaps implementing it in Python?
I'll let Matt field that one.
Great.
So we definitely could do that. Currently, the backend is just a .NET Core application that purely just serves the raw data to the front end interface. The reason to go with the JavaScript implementation was to basically make it accessible anywhere. Python can run on almost every application, but going that extra step for a JavaScript application just gives it a little more accessibility because all you need is a web browser.
Okay. Another question. When would the CMM Wizard be released? Is that yours, Zhao Ying?
I would defer to our software development team to answer that. We do have our own milestone, of course, by the end of fiscal year, but I'd like to invite our software engineer team to answer. Thank you.
We are going through some internal testing right now, and we plan to have a hosted application by the end of the fiscal year. That is the target.
Great target. Another person, if I have a question, whom do I talk to about the CMM Wizard or the CMM Excel Workbook?
So you can always use the EMI-SIG platform to submit your question. Berna has the excellent link there that she can share with you. And if you know us as colleagues, you know, certainly you can write to us directly. But if a technical challenge, I think the best way we can resolve it is use the TSR venue. And in the CMM Wizard and the CMM Excel Workbook, we try to set up the user feedback link for you to submit your questions. So there are multiple venues that you can use to ask us questions and get help.
Matthew or Brett, did you want to add anything to that?
I think the best channel is to use the EMI-SIG platform to maintain consistent and messaging through the program. We're always happy to take questions, but for anything technical or formal that might result in a change, use the EMI-SIG email.
Great, and I'll reiterate that. I'm more than happy to help direct people on the EMI-SIG platform, but man, if it gets technical or chemical, I'm tossing it back to you. We do have one more question. Why is the HCN and chemical mixture model analysis emphasis on Pack 2 values?
So if you happen to have a chance to listen to our Pack 2 talk, you know that Pack 2 is the default recommended threshold values or concentration limits that we use because Pack 2 is the level indicates, you know, the concentration or exposure that the personnel may experience and then impact their ability to respond. So that's why in our method, we always default to Pack 2. However, in the planning or exercise situation, you obviously can use more extreme, which is the lethal, that's Pack 3, or more benign situation, Pack 1, to understand the boundary of the chemical exposure. And that's actually reflected in a lot of dispersion models that Cliff and John are very familiar and experts on.
Any other comments to that, Brett?
I think when, as part of the development and a bit of updating of the CMM Wizard, we try to provide a very robust envelope so that just what Zhao Ying said, there's flexibility in how the planning and analysis can be conducted. You can develop an envelope for mixtures or scenarios. And as a quick aside, the one thing that you can do with this version is share scenario files amongst yourselves. And so When you download a scenario output, that can be reloaded to another machine from another user. So it can save you a lot of time if you want to trade notes on a particular exercise scenario.
Thank you. And Cliff just wanted to add to your comments earlier. He said that the Wizard is easier and quicker to use than the Excel Workbook. Both should produce the exact same results. The Wizard also allows you to quickly look at the results at multiple distances downwind, and it allows you to save your results in a concise file without having to save the entire and very sizable Excel Workbook.
All good qualities.
Thanks, Cliff. Yeah, our Excel workbook is about 1 megabyte, right? So if you have 10 cases, you immediately have 10 megabytes. But the Wizard right now, you can easily export the result and import the case back. It's in text format, so that's very portable compared to our existing workbook.
Wonderful. I know that those that were on the TEEL presentation, the one just before this, heard a little bit more about the meteorological. So this question might feed into that as well. It says, does the CMM Wizard use the meteorological data?
Absolutely. The meteorological data are quite critical for us to come up with a proper concentration level or the exposure level, concentration of a chemical in the mixture. And that's why Cliff was emphasizing earlier on the importance of knowing the conditions of when used to arrive at that concentration that we will eventually use as input in our CMM.
Wonderful. Do any of you have any more comments before we close out today, which also is the closeout for all of our presentations for this week? We'd love to have your closing thoughts on this.
Well, sometime soon there will be some folks that will be requested to do some external testing. So if you have an interest, let us know.
So true, so true. Well, thank you all again for your excellent presentation, for being available for us. I know it's kind of late on the East Coast for any of you. Please remember, those of you that are attending, fill out your survey forms. The last one you have to do today. And also don't forget to go on the app and fill out any requests you may have for the awards. So we've got Subcommittee of the Year, we have Contractor of the Year, Best Presentation, Best Exhibit. So thank you all again and have a good evening.
Thank you.